Okay, guys, we're finishing chapter 5 today. We've done improper integrals already. We're going to review the first type. I don't even think I assigned any. And then we'll do the second type, and then both Friday and Monday are going to be work days, review days. Maybe I can find some AP questions that would help. And your test is Tuesday, Wednesday. You should have done the ones yesterday. I can put the solutions up. So you can work on that when I'm done with this, even today.
It's just so tough, though.
Okay.
Not bad.
Now, we have to talk about this. This is the improper, there's two types of improper integrals. The first one is when you integrate from some number to infinity. And if you don't write how to do this correctly, if it's free response, you will not get the points. It's been on the listserv, somebody asked the question, and so, yes, we have to write this correctly. So, I'm going to take the integral from a to infinity of f of x dx. Well, it's improper because I don't have an ending point. Sometimes it'll be a finite area, sometimes it won't, just like our series. So I do the limit, I'm going to call it t. You can call it whatever you want, but it's a to t, and then I'll let t go to infinity. And that's the correct way to write it. And yes, I was picky with you guys back in chapter 8. They're going to be picky on the exam. And that's the way you have to write it. Do we need to do an example?
That's all you need to write.
That's what you, well, no, you have to do a problem. Yes. Okay, so, and you should have an example on your handout. Yeah. That's the promise of notation. You've got to make sure you have the right notation. Okay, are we ready? You can try it while you're waiting for everybody.
And the antiderivative, so like if dv equals x dx, e then x.
No. Okay, let's look at the graph. This is 1 over x, and this is going to be positive side of my axis. And so here is, we're going to integrate from 1 to infinity. I want that area, because remember, this is a signed area. And there it is. So we're going to take the limit as t goes to infinity, and let's integrate 1 over x. What is that? It's the natural log of x, evaluated at 1 and t. So it's the limit as t goes to infinity. It's the log of t minus the log of 1. What's the log of 1? That's 0. What's the limiting value of the log of t? So if we go here and there's the log function. Does it have a limiting value or does it go off to infinity? It goes to infinity. So you would say that this diverges. It's basically the integral test, but there's another type of improper integrals. This is one type. We'll do another one in a second. So what they're saying, actually, if you think about it, I was just thinking about this, remember, this is the area under the curve. It turns out to be the log function. So we know the log function does get infinitely large. Not very fast, but it does get infinitely large, which then tells you that this area under this curve will also get infinitely large. There's your connection between 1 over x and log of x. Kind of cool. Should we try that one? This one is a problem on both sides. And, you know, I know what this looks like without doing any calculator work. I don't know if you guys don't, but do. If x is an integral, it's going to start at, I'm going to draw the picture. It's symmetrical. When x is 0, it's going to be at 0. When x gets really big, what's this going to do? Yeah. It's going to go to 0. So it looks like this. It's an even function. Pardon? I can. Be careful if this drops below the axis. Just because this might go to infinity and the negative one will go to infinity, you still can't say it's 0 because you don't know if you're at the same place at the same time. So you'd say it still diverges. So you're right. Let's do this. Let's just take the right side because that's easier. 0 to infinity of 1 over 1 plus x squared. And we have to know our integrals so we can recognize this. So I'm going to rewrite this as the limit as t goes to infinity, 0 to t of 1 over 1 plus x squared. I know it's a pain to write all that out, but that's what you have to do if this were free response.
Well, would we be able to do that? Did you know what it looked like?
Yeah,
Was it symmetrical?
and it doesn't matter. I just like to have the visual side of it.
So you still just go from 0 to...
You still, well, then you could go from negative infinity to 0 of the same thing. And you'll have to be,
Can you skip that first step?
See, Brandon, we work good together. Now, can I have a present?
pardon?
Can you skip this first step to from
Well, it is the same step. I mean, you could rewrite it plus that one. I would say this is going to be twice this. Let's put the 2 in there. Because I know what it looks like. But that wasn't really hard to know what it looked like. You should know that it's even, because how do you find out if it's even? F of minus x has to equal f of x, remember? They expect you to know even and odd on the exam. So if you substitute in minus x, f of 1 plus the opposite of x squared, which equals 1 over 1 plus x squared, which is equal to f of x. So I do know I have symmetry. I should give you that old thumb. No, not unless they ask. You might have, but you might have to use it. Okay, let's integrate this. What is this? Matt, you remember what this is?
Yes.
What is it? Which one? It's the inverse tangent. And we will evaluate at 0 and t. So it's 2 times, and we have the limit as t goes to infinity of the inverse tangent of t. We had some homework problems a long time ago on that. And then it's minus the inverse tangent of 0. That's 0. And so what I do, if you know what inverse tangent looks like, you can answer the question. But if I don't know, if I don't remember what it looks like, then I'm going to say, here's my little scratch work. Because they would only look for your answer. You could even say scratch work, don't grade this or whatever. This is the inverse tangent of t is going to become, sorry, I don't want that, of infinity. Let's rewrite this, because I don't know what that is. So inverse tangent of t is equal to my angle, right? Because an inverse tangent is an angle. So it's saying the tangent of theta is equal to t, or the tangent of theta is going to be going off to infinity. Remember what the tangent function looks like? Right, it looks like this. What angle will give you infinity? That's pi over 2.
The inverse just on its side, though?
Yes. So it looks like this, the inverse. So it's your horizontal asymptote was your vertical asymptote. No, it's pi over 2.
But now the inverse...
The domain is going to be from minus pi over 2 to pi over 2 of the original function. That's correct. Because if you do, then I have to have my next inverse tangent. There's a whole bunch of them.
Yeah, but
And I don't have a function. So when on our tangent function, we will limit ourselves to be here. And then I just end up with the one curve. And there's only one answer. That's why we restrict our domain. Pardon? Okay, that's pi over 2. We're going to substitute that in there. So in place of this limit is pi over 2. And 2 times pi over 2 gives me a total of pi. That's for the entire thing. It's pi over 2 for the left one, pi over 2 for the right. Let me draw that in there. That's pi over 2, and that's pi over 2.
you should copyright that. What's it called? See, right now, Mr. Copyright.
It is cool. Okay. There are more examples here, we might as well review this. What has to be true about p? No? Greater than 1. This is the p series. And I've seen that on the test. Except they'll do it like this. They'll say integrate 1 over x to the 2p. What does p have to be to get it to converge? And 2p would be greater than 1, p is greater than a half. I've seen that question. To me, it's a nice, easy question. Yeah, the p series and the integrals really kind of go hand in hand. And I think that was it, wasn't it? Okay. Oh, yes. About the week before the exam, I will be hitting on series the whole time.
More practice on BC type stuff with.
Oh, yeah, that's all we're going to do when we get there.
More focused on that. Focus on
This is BC.
rule and other stuff that we
You have to know trapezoidal rule because you have to know it. Well, hopefully you remember, but not everybody does. Probably 90% don't. But we will, when we do our study sessions, if we have study sessions, we will be focusing on BC topics.
Go smack the school board. I thought the study session was at your house.
That's the Sunday one.
What? There's a Sunday one?
Well, I'm going to go do the next one. Okay. Now, but that's what we'll be focusing on. And then the AB study sessions are open to anybody who wants to go to whatever topic we're doing. Right, they are, but BC's not as packed. Okay.
Oh boy.
Did I open this other one up?
It's coming up.
No. Okay. No, I don't want that. Okay, so we're going to go and get the other worksheet out, the type 2 ones. And I got to go back.
No, not bigger. It's just heavy.
Okay, I'll have to fix these titles. Thought I
We're
did.
gonna have Fiora, so you
There it
guys
is.
are gonna have Miss Fiora. We have a guy. We have a new guy. I know.
Okay, this should be 5.10. Okay, if you have a function discontinuous on an interval, this is one where you have a vertical asymptote. This is not the limits at infinity. This is it's very similar though. The type 2 is a vertical asymptote. Let's go ahead and look at the problems. That's all the theory. Come back and look at that. This one. This is a vertical asymptote. And I don't exactly know where. We have x is equal to 2. Turned out to be at the end point. If I integrate 1 over x minus 2 from 0 to 5, I'm going to have to break that up. Yeah, you have to recognize there's a vertical asymptote. My first year of teaching AB Calc, I actually put on one with a vertical asymptote on their test, and it worked out. It just happened to work out.
Just not include 2.
Well, we'll do exactly what we did before. We're going to take the limit, and we're going to call this t to 5, and we'll let t get really close to 2. It is from the right. And, well, I don't know if I have to say, but it's x minus 2 to the what power? This is a power rule, so it's what?
Right?
Yes, I do have to put in the, that's correct. Now, speaking of which, just like the square root of x, because I've been a part of this listserv, I read all this stuff, and there was discussion about the continuity at 0, and they're saying it is continuous at 0, provided that you do this over all the numbers and complex numbers. It's not continuous at 0 on the real numbers, but if you include complex numbers, there are complex answers. So yes, it is continuous at 0, but that's what you would learn in an upper level math class. I thought that was interesting. I hadn't thought of it that way, because in calculus, all we deal with is real numbers anyway. Okay, so let's go ahead and integrate that. T is going to go to 2 from the right, and this is going to be x minus 2 to the what? 1/2 divided by 1/2 is times by 2. And we'll evaluate it at t and 5. And if it's going to converge, that's going to have to go to 0. I'm curious to graph this. I really don't know what it looks like. So we'll go ahead and substitute that in there. So first we put in 5. There's no limit there, so it's 2 times 5 minus 2 to the 1/2, and I know it seems silly to write that out. I could have just written 3. But if somebody wants to read my work, then they could say, where did 3 come from? At least this shows that. And then it's minus 2 times the limit. as t approaches 2 from the right of the square root of x minus 2. I prefer to see it in root form. Well, this is 2 times the square root of 3. And if I wrote this, and then I wrote the next line wrong, I still would probably get, depends if it's like be considered a copy error, but at least if there's some other parts later on, I'll get some of the answer. I'll get some of the points. Pardon? This is 5. No, it should be T. And it's a good thing, and that would have been a copy error. As long as I finished the problem correctly, they would give it to me, because I just copied it wrong. But it's kind of important. And so we substitute in 2 from the right side, because you can't put in 2 from the left, as you said, and I get the square root of 0. So the answer is 2 times the square root of 3. I don't know how many more. Pardon? There's there's a lot left. Maybe tomorrow we'll graph it. I kind of would like to know what it looks like. You really don't? Yeah, I was going to use the Inspire CAS, and then you can integrate it to infinity. Well, okay. On the AP exam, if you have a CAS, the only thing you're allowed to use your CAS for are minimums and not minimums. Sorry, I said that way wrong. Are where the function is 0, looking for the zeros, looking for intersection points, doing a numerical derivative or a numerical integral. And last year, the students used it for just an integral because they decided they were going to integrate the function. The intent of the problem was to use a definite integral and just put it on your calculator. Well, they had to use the calculator anyway, but they used the calculator to find the antiderivative, which you could do by hand, but they didn't get the points because they used the CAS part. It was assumed they used the CAS part. Yes, but the integral was such that I could have done it in my head. Yeah, and so I don't know why they were fussy about that, but they were.
How many points was the problem?
I don't remember. I graded it. I just don't remember. It was a free response. Mm-hmm.
Was it anybody from our school?
I don't know. There were a number of students who did that. The only reason we know that it was probably CAS is because when you get the exams, you get a booklet of 20 or 25. I think it's 25. And you get all the same, you look at the numbers, you get all the same, you're reading the answers and go, oh, these are all the same. Then you go back and look, oh yeah, they're all from the same school. So that's why we assumed it was CAS. But that's still not fair. Okay, guys, we're going on. How do we integrate this one? And we got a problem where? Okay, this is all a BC topic. So it's the limit as t goes to 0 from the right side, and we'll integrate from t to 1 of the natural log of x. Now, you guys remember that, or do you want me to review this with integration by parts? Nope. Oh, I better do it then. This is integration by parts. A regular u substitution will not work. We are going to call this x. Not x. We're going to call that u. And I don't want it to be v or dv because I don't know how to integrate that. And so I just said that this is dv. So u is equal to the log of x. So du is equal to 1 over x dx. And then dv is equal to dx. You need those differentials because it doesn't even make sense if you don't have them. So v is equal to x. So it's u times v. So it's x times the log of x minus the integral of v du. So it's x, and then du is this. So just substitute in 1 over x dx. That's right. X log x minus dx, which gives you x log x minus x. Move that guy? Oh, I can't. Good. Okay. Yeah, this is one of the longer.
Is that all you do?
No, because guess what we have to do? We have to substitute that in now over here now. Right? Yes, you do.
No, like the one over there.
No, that's just my integral. Personally, I would have written down x log x minus x because I've done it so many times. I know it now. And it's kind of nice if you get it on the exam, especially if it's multiple choice. That would save you time if you knew that one. if it comes up. I think it could come up.
So that. What about on part 2? Don't you have to do X, L, and X?
If you know it, I don't know about that. I guess I would just for safety. Okay.
Do you think I need to do this?
Wait, which one? With HO2?
Nope.
What?
Okay, so let's go ahead and put 1 in. It's 1 log of 1 minus 1
Because they know they can't pass their own.
minus.
No, HO2.
Okay, you guys, put in the t. T log of t minus t. And we're going to let t approach 0. Well, what's the log of 1? Okay, so this is negative 1 minus, I get 0 times the log of 0 plus 0. Well, that's what it is if I substitute it in. But that's 0 times infinity, negative infinity. Oh, you should be thinking about this. Matt, what is 0 times infinity?
0.
Nope, because 1's going to 0, 1's going to infinity. 0 times a number is 0.
One of those things.
No.
I need to find this limit. It's the limit as t goes to 0 of t times the log of t.
Is it infinity technically a number?
Nope,
That's actually
infinity is a concept. So when you do 0 times infinity, it's like tug of war. You're pulling in that direction, I'm pulling in this direction. Sometimes somebody wins, sometimes nobody wins.
But if
You don't know. This is indeterminate.
even
What did I hear over there? Oh, I thought I heard the right word. No, this is indeterminate. How do you do?
something like this before?
4.5.
Yeah.
What'd you say? You do L'Hopital.
Yeah, that's what it is. Mocktail.
Now, if this is free response, listen up. If it's free response, you have to show that. The fact that you say L'Hopital, they don't care. They want to see this. That is what, because that's what triggered you to say L'Hopital. So, Kevin, you suggested what?
Is it T on the bottom?
Yeah, we'll put T on the bottom,
Divided by
1 over T. And so when we use L'Hopitals, it's the limit, and that's just habit because that's the way I was taught. Everybody kind of does it too. The derivative of the numerator, which is 1 over T. Have you memorized the derivative of 1 over T yet? Negative 1 over T squared. I can't help it. I've just done it too many times. Then we do T squared. So, and there's a negative sign there. And so I end up getting what? This goes away, and I end up getting T, right? So the limit as T goes to 0 of negative T, which is 0. Okay?
0, 0.
Well, I gotta go back. This ends up being 0. So the answer is negative 1.
Holy Hannah.
nice catch.
You don't like multi-step problems. That's engineering, nothing but multi-step problems.
Holy polypack.
I think I'm not getting an engine.
I have for right now. She's right.
She's my favorite.
She just knows how to do it.
Get better around the block.
Oh, I'm not going anywhere.
In the teacher's sense.
I just want to check what that one is. Okay. Okay. How about that one?
Well, you didn't. Yeah, those are you guys that always said, "Oh, it's our turn to pick the test date or whatever."
Use a comparison on that.
No. You guys get to pick the test date. Yeah, like she'd ask you for like the FR.
Okay, well, you guys, what about this one? This is a type 1. Oh. Okay, we can skip that one. But here's what you would do with this.
What's the difference between type 1 and type 2?
The type 1 are you're letting the
regular one?
the x's go to infinity. The other ones are where you have a vertical asymptote.
What?
This is a horizontal asymptote.
Oh.
And then I would do this, dx. plus the integral of e to the minus x over x. My guess is I'm going to have to do integration by parts for that one. Yeah, we're going to do the next one. The next one has to do with the comparison test. Remember that, Kevin? The comparison test.
No,
I remember that. That's
let's see. How much are we gonna learn today? Yeah, we're done.
That's it.
It's like 2 units.
And it says,
2 units.
It's a unit.
2 days.
well, we already did the other one, I just reviewed it. Here's f of x. This is convergent. And g of x is trapped in here, so it's less than that. This one converges, then what would be true about g? Converges, okay? It's the comparison test from chapter 8.
I like how we got that.
Me too. That one's easy.
You gotta figure out what to compare it to. Okay, I'm gonna need a calculator probably for this, because I need to compare it to something. Why did you choose that? Is e to the minus x squared less than e to the minus x? Now, it doesn't have to be in the beginning. It only has to be at the end. Because when I integrate in the beginning, that's finite. Starting at what, 0? That's finite. This is the part. And if I'm remembering correctly, e to the minus x squared comes like this, whereas e to the minus x is below that. But then at the end, it's going to be above that. And so I can show this one converges.
It does.
I don't know. I got to do it.
It does.
How do you know?
Because the X.
This is e to the minus x.
Yeah.
Oh, okay. Well, let's go ahead and do it anyway, just to make sure. So it's the limit as t goes to infinity. That's good thinking. From 0 to t, and you could argue it by the way, but it's e to the minus x. We'll find that one. Remember, it's only the end behavior that we care about, because when I integrate from 0, let's say this is 0, I mean, these are finite areas. Who cares? I know that converges, but the question is, what happens to it when x gets big? Okay, so this is going to be, can we do this without a u substitution? It's negative e to the minus x. And I can check it, take the derivative. That's where the negative sign came from. It should say 510 anyway. So it's the limit as t goes to infinity, and I think we've done this before. It's minus 1 over e to the t minus negative 1 over e to the 0. Signs are tricky. You know by looking at the picture, it better be positive. What does this end up giving me?
0.
That gives you 0. This becomes plus. So the answer is 1.
How is that possible?
Well, the area under the curve.
But why don't you think it's possible?
Isn't there a lot of area?
No. E to the x goes really fast. That's smaller than 1 over n squared. Shall we find out? That's but I'm going to bring up my calculator.
Yeah, let's take a look.
It's like you're adding a really small.
Should we, you think e to the minus x is smaller than 1 over x squared?
Okay, it's even negative X.
Oh, it was so cool. Watch me zoom out on this. And by the way, those of you who have a CAS calculator, if you go to education.ti.com and you go to, and that's true for the 84s too, you guys. Guys, if you go under the activities, the downloads or whatever, there's lots of activities and you get the TNS files. I don't know why it does that. It's so annoying. Graph. Okay. Should we graph 1 divided by x squared? I'm curious. It's got to be smaller than that, I swear. Press enter. Okay, Justin? Don't get me sick.
I was trying to get on the recording.
You're weird. Okay. Now, all I have to do is tab, and I come down here, and now I can do e to the minus x. I always do that wrong. There. That doesn't tell me anything. Have a seat, please.
Someone knows me too.
Okay. Now what I can do that you can't do, I can do that.
I can do that too, actually.
And then, oh, I'm thinking of an iPad. Okay. I know I did. Oh, wait. I know. Okay, so now I want to... What do you think? It's below 1 over x squared. We know 1 over x squared converges.
If we're converges.
It has to converge. Now do you believe it?
Convergence by the comparison test.
That's like exactly the other
Where are you graphing negative e to the negative x? Or e
Yeah.
to the x squared?
Well, I did both.
Oh.
E to the negative x on the top.
And I don't know where my label went. It's off the screen. But see, the red is 1 over x squared. The green is e to the negative x.
We know that.
Wait, no, you just said
e
it
to the negative x
backwards.
squared is smaller than e to the negative x.
You said it backwards.
I might have. The red one is 1 over x squared. The green one is e to the minus x. Let's do it. Let's add in e to the minus x squared.
That's clear. No. Put it back.
X squared. In the beginning, it's not. Now, this would be a different color.
Yeah, okay.
See, in the beginning, it's not. But look at that. That's underneath e to the x. E to the minus x. And clearly underneath 1 over x squared. So as long as you know it's smaller than the other function, you can use any function that you know converges. 1 over x squared converges by the p-series. Yeah. So do you want to go back and look at that other one? No, that was e to the minus x squared. Yeah, e to the minus x squared is, look how fast it goes to 0. Yep, you have time to work. I can answer questions on integration by parts.
Well, I have to do that whole algebra pattern because
Just made my brain go dead.
Why?
We learned 2 pages of time.
Oh, I know. This was nice about this class. Remember AB? We were always doing stuff. Oh,
You don't want to catch up.
I don't know why that doesn't work.
It's cheap.
Yes?
Working tomorrow?
Yes, tomorrow's a work day.
Oh. Do you have $1 I can borrow?
I'll put it back. He stapled me yesterday.
I don't think I do.
Wait, you do or you don't?
I don't think I do. There we go. Nice.
Mrs. G, can I do the first 3 problems on every page?
Just do it.
No.
Do you want me to do any integration by parts problems? I did a bunch.
I would, but I have to do algebra first.
Okay, so. Oh, you don't?